Good day everyone, I am Novi Andreatti Dahan, your first reporter of Group 6. So today we are going to report the Chapter 4 entitled Network Interface Cards. So these are the topics to be discussed. So topic 1 to be discussed by yours truly, topics 2 and 3 to be discussed by Mr. Janelle Wabe, topics 4 and 5 to be discussed by Ms. Jimena Torillo, and topics 6 and 7 to be discussed by Ms. Jonna Talledo. So before I am going to proceed with my topic, so first let us elaborate what is network interface card. So network interface card is also known as a network adapter or a network card that plugs into an adapter slot inside the computer case. NIC performs two crucial tasks. Number 1, it establishes and manages the computer's network connection. Number 2, it translates digital computer data into signals. So in other words, the NIC establishes a link between a computer and a network and then manages that link on the computer's behalf. So let's proceed to topic 1 entitled From Parallel to Serial and Vice Versa. Because of the nature of the connection between most NICs and the computers to which they are attached, network adapters also manage transformations in the form taken by network data. So most computers use a series of parallel data lines. So as you can see in the figure 4.1, so that is called a computer bus or a bus for short, that is to send data between the CPU and the adapter cards. So this allows the computer and adapters to exchange data equally to the number of lines that extend between them. Because data travels along multiple lines at the same time and those lines run parallel, both metaphorically and physically, this type of data transmission is called parallel transmission. These bits of data follow one another in a straight line or a series. This type of transmission is called serial transmission. Thus, one of the most important jobs a network adapter performs is to grab outgoing transmissions from the CPU in parallel form and recast them into their serial equivalents. So look at the figure 4.1. For incoming messages, the process reverses. So the network adapter grabs an incoming series of signals, then translates them into bits and distributes those bits across the parallel lines that communicate with the CPU. So let us know what is the difference between parallel and serial forms of data. If we say parallel transmission, it works like a multi-lane highway. So each lane carries part of a stream of traffic information between sender and receiver at the same time. The larger the number of lanes, the more traffic or information the highway can carry at any given moment. While serial transmission resembles a one-lane road only compared to parallel transmission. So obviously, a serial line is inherently slower than a parallel line because the speed of the line alone limits the amount of data a serial line can transmit. For a parallel set of lines, both the number and the speed of the lines play a role in how fast data can travel. So the keyword here is buffer. So actually, what is buffer? So consequently, one of the most important components on a network adapter is memory, which acts as a holding tank or a buffer. The next keyword is bus width. So what is bus width? Bus width is the number of parallel lines that make up a particular kind of computer bus. So that is bus width. For example, ISA supports 8 and 16-bit bus widths. EISA and MCA support 16 and 32-bit bus widths, and PCI supports 32 and 64-bit bus widths. One significant improvement in the IBM PC or AT, AT stands for Advanced Technology, was its 16-bit bus. So this bus became so prevalent that is called the Industry Standard Architecture, or also known as ISA bus. For years, this was the primary bus found on PCs. So today, you would be hard-pressed to find a new computer that has an ISA included. The late 1980s to early 1990s witnessed the introduction of 32-bit buses, of which the 64-bit capable peripheral component interface, or PCI, is the fastest and most popular in use today. So each of these bus types is explained later in the section titled PC buses, to be discussed by Mr. Janelle Wabe. So the keyword here is transceiver. So transceiver is to transmit data across the network medium, or a network adapter must include or access a device. So that is designed for the specific medium in use. So look at figure 4.2. 4.2 shows an Ethernet NIC that includes a female BNC connector, where the base of the T connector attaches for a Ethernet network, along with an AUI for fiber optic or other selected media, and an RJ45 for 10 base T. With the appropriate setting chosen, that card can be told which attachment to use and brings the appropriate circuitry to bear. For both Ethernet and 10 base T, such as NICs, include a built-in onboard transceiver. For fiber optic, an external transceiver must be connected to the card through the AUI port on the back. So with most newer cards, only one type of media connector is supported. Network adapters that use more exotic media, for example, certain wireless technologies or fiber optic cable, usually support only that one medium. So in that case, it's necessary to make the right connections to the card to establish a network connection, whether wired or wireless. So network adapters also handle important data packaging functions, as they serialize outgoing parallel data streams from the CPU and translate incoming serial data streams from the network medium into parallel data. So the NIC packages all the bits into orderly collections called frames. So the keyword here is frames. So what is frames? Frames are the fundamental unit of data for network transmission and reception. So much of the important processing that network adapters perform not only involves creating, sending, and receiving frames, but also dealing with frame level errors and incomplete or unintelligible frame structures. Another keyword here, which is packet. So the term packet is often used to describe the unit of information sent between network devices, but the term frame is more accurate when discussing the unit of information that is handled by the network interface card. So frame is more accurate compared to the term packet, because the frame is more accurate when discussing the unit information. So other important roles NIC plays are packaging and preparing data for transmission across the medium, and managing access to the medium to know when to send data. So network adapters examine incoming network frames and check to find any address to the computer where the adapter resides. So the NIC acts as a gatekeeper and permits inbound communications aimed only at its computer to pass through the interface and onto the CPU. So the NIC's role as a gatekeeper points to another important function network adapters provide, determining whether the computer is the appropriate recipient of data sent across the wire. So each card has a unique identifier. It is called a MAC address. So the keyword here is MAC address. So MAC address that takes the form of data programmed onto read-only memory, or ROM, on the interface. So the IEEE sponsors a manufacturers committee that design an addressing scheme for network adapters and assigns unique blocks of addresses to NIC manufacturers. So each new NIC built has a unique identifiable address encoded onto it, guaranteeing each computer its own network address. So the gatekeeper function simply looks for an address bit string in the decoded frame that matches its own address or that corresponds to a valid general delivery address. So MAC stands for Media Access Control. By now, it should be clear that the NIC is intimately involved in managing and controlling network access, and its role goes beyond creating a physical link between a computer and a network medium. So that's all for the topic 1. So I will give the floor to Mr. Janelle Wabith to discuss the topics 2 and 3.
Hello everyone, I am Janelle Siwabi, the second reporter of today's reporting. I'm going to discuss to you my two topics about PC buses and other PC interface for networking. So, let's go! Now, I'm going to discuss first about PC buses as my first topic that I'm going to discuss to you all. So, what is PC buses? PC bus When PCs were introduced, only a single bus design existed, an 8-bit bus of limited speed and capability. But as technology evolved, other buses came along, and some have already left the scene. Today, a variety of PC bus types, also known as bus architectures, appears in modern PCs. Each bus differs in its layout and configuration, with a single exception, as you'll soon learn. Therefore, it's imperative that any adapter card you want to use matches the bus types of the socket. So fortunately, as figure 4.3 illustrates, distinguishing among these bus type architectures is straightforward. So here you can see at the image, figure 4.3 about primary PC bus architectures. You can see ISA, EISA, microchannel architecture, PCI, AGP with monitor connector. So we'll discuss each one of this. So what are these primary bus architectures that have been shown in the picture? Well, these are the following facts about bus architectures. First is industry architecture. Industry Standard Architecture. Again, it's Industry Standard Architecture or ISA. The ISA bus originally appeared in the first PC in 8-bit form with the introduction of the IBM PC AAT in 1984. The bus size doubled to 16 bits. Even so, the top end of the rated bus speed for ISA remains leisurely by today's standards. 10 MHz, the same speeds as blazingly fast 80286 PCI processor had when it was introduced in 1982. So the second bus architecture is Extended Industry Standard Architecture. Again, it's Extended Industry Standard Architecture, or also known in short EISA. So by 1988, a 16-bit bus was no longer sufficient to handle the demands that high-end network servers put on a PC bus. A consortium of PC clone vendors led by Gary Stimac of Compaq Computer developed this 32-bit EICA bus. Through mechanical and electrical trickery, EICA slot could accommodate either 16-bit ISA or 32-bit EICA adapters. So the third PC bus architectures is Microchannel Architecture, short for MCA. At around the same time EICA came along, IBM introduced its PC2 computers, which features the 32-bit MCA bus. MCA can work in 16 or 32 mode and supports a variety of bus speeds from 5 to 66 MHz. So the fourth bus architecture is Peripheral Component Interface, in short for PCI. So the introduction of ever faster CPUs brought about a parallel need for faster buses. Manufacturer created the idea of a local bus, which uses the same technology the CPU uses to communicate with RAM, and that coprocessor used to communicate with peripherals. So the peripheral component interface supports bus mastering and was the first to accommodate the Microsoft plug-and-play architecture as well. Finally, PCI supports interrupt sharing on PC so that any and all PCI adapters can share a single interrupt request line, or in short, IRQ, without requiring a unique IRQ for adapters. So the next one is PCIX. PCIX, a newer PCI specification. PCIX 2.0 is a backward compatible to PCI, but supports speeds from 66 MHz to 533 MHz, providing data transfers from 500 Mbps to 4.3 GPS. So next one is PC cards, or also known as PCMCA cards. These credit card size expansion cards are used primarily to add functionality to laptop computers. A variety of network interface cards are also available in this format, including wireless. So second to the last is accelerated graphics port, or in short, AGP, an Intel-developed high-speed connection that links a display device directly to computer's memory. AGP is a special-purpose bus that works only for computer displays. So, the last but not the least, developing bus standards. Currently in the development in a serial bus called PCI Express, formerly named by 3GIO, that will likely operate at speed from 2.5 GPS to 10 GPS. Because PCI Express can set up in lanes, several lanes can be combined to provide tremendous transfer speeds. These speeds are expected to reach 5 GPS and beyond. Although PCIX bus slots will be backward compatible with existing PCI boards, PCI Express hardware will maintain only some backward compatibility. A continuation of my report about PC buses, there is an important note to follow. Although it's important to understand the characteristics and capabilities of these PC buses, it's not necessary to memorize their chronology or the companies that introduced them. So here at the table 4.1, showing the common bus type used for networking. So this table 4.1 is a quick reference only for several bus types that are used for networking. We can see at my previous discussion about ISA, EISA, MCI, NCA, PCI, PCIX, PC card, or PCMCA with their speeds and their bus size and the usage of these bus types. So when working with PC buses, the most important requirement to remember is that the adapter you install in PC, whether a network interface or some other peripheral device, matches the socket and the PC where you wish to put it. As you become more familiar with what's inside most PC, you'll quickly recognize the most incorporate slots for more than one bus type. So a note to remember for network servers where fast network access is a key component in a network performance, use 64-bit PCIX and CIs whenever as possible, because traffic aggregates at the server. Spending extra money on a faster network card pays for it quickly. So that's it for my first report on the first topic, PC buses. Now I'm going to discuss to you the second topic of today's reporting is about other PC interface used for networking. So what are these PC interface used for networking? Although the following interface technologies don't replace the buses found inside most typical PCs, they do offer other ways to attach computers to networks. As with bus types, a computer must be equipped to accommodate devices built for any specific interface to successfully attach the interface to that machine. Typically, such interface may be added to a PC by inserting an adapter card for that interface into a bus. So now I'm going to show you the PC through the bus connector and adapter these two are the most common use such interface. So the first is Universal Serial Bus, or again, it's Universal Serial Bus or USB 1.0. USB 1.0 is relative low-speed serial interface that operates at maximum bandwidth of 12 Mbps. It's primarily used for low-speed peripheral devices such as mice or mouse, keyboards or joystick, but may also be used to attach printers, scanners, telephones, or some video device to a computer. In networking, you most likely will find USB being used as an interface for wireless network adapters or as the attachment for cable or DSL modems. Now today that are the most relative use is USB 2.0 as the successor of USB 1.0 and can operate up to 480 Mbps, up to 40 times faster than USB 1.0. This interface is being used for external hard drives like CD or DVD burners, flash memory card readers, high-speed scanners, wireless network adapters, and digital cameras. And lastly, FireWire. So this FireWire is also known as IEEE 1394. FireWire is a high-speed serial bus jointly developed by Apple Computer and Texas Instruments that operates at bandwidth up to 400 Mbps. It is also used for networking and to attach digital cameras and video devices to computers. The popularity of FireWire and the new USB 2.0 standard has prompted many manufacturers to offer a combo cards that sport both a FireWire interface and a USB 2.0 interface.
And that's all for my discussion about the two topics, PC buses and other PC interface used for networking. And now we're going to hear the discussion of Jimena Turillo on her discussions of her topics. See ya!
Principles of NIC configuration. So when we say principles of NIC configuration, once you match a network adapter to a slot in a PC or plug it into a serial bus, your next step is to configure it to work with your computer. So in a perfect world, this might mean opening the PC, setting or positioning the network adapter in a bus slot, closing the PC box and turning on the system. So alternatively, it might only require plugging an external network interface into a serial bus port. So it's very handy for laptops. As soon as a computer boosts up, the network would be available, but unfortunately, it isn't usually this easy. So in an effort to approach this level of perfection, Microsoft introduced its plug-and-play architecture with the Windows 95 operating system, which is the Power on Self-Test or the POST or the POST. So the Power on Self-Test sequence and negotiate a working configuration without requiring human intervention. So if the motherboard or the operating system and all adapters support plug and play, this works well. But if some devices do not support plug and play, these types of devices are referred to as legacy devices. Or if any device fails to conform precisely to plug and play requirements, manual or the human intervention is required. So for computer systems that do not precisely fit the plug and play model, or for PCs that run operating systems that do not support plug and play, the manual configuration is essential to make any NIC work properly. So on the next slide, we have the NIC configuration involves working with three types of PC settings. So these are the interrupt request line or the IRQ, and the second one is the base I/O port, and lastly, base memory address. So you can be thankful that today's operating system and PCI Boss plug and play NIC cards make manual configuration largely unnecessary. However, older NICs or older operating systems may make manual configuration a necessity from time to time for a tough treatment of expansion and configuration details. So in the fourth slide, we have the making the network attachment. So network adapters perform several vital roles to coordinate communications between a computer and network, including the establishing a physical link to the network medium. The second one is generating signals that traverse the network medium. Third, receiving incoming signals. And fourth is implementing controls for when to transmit signals to or achieve signals from the network medium. So in every networking medium has its own physical characteristics that the adapter must accommodate. Whenever you encounter such as a card, read the card, read the manual to get the information. You need to configure the card correctly. So choosing network adapters for best performance. So as the focus of network traffic on workstation, enough large volumes of traffic on network servers, even those with more than one network interface, NICs can exert significant influence on network performance. So when selecting a network adapter, you must first identify the physical characteristics that the card must match. So some of these options suit servers better, whereas others work equally well for servers and clients. All help improve overall network performance. So these hardware enhancement options include the direct memory access or the DMA. The second one, shared adapter memory, shared system memory, bus mastering, RAM buffering, onboard co-processors, and the security features. The next one is traffic management, improve fault tolerance, and lastly is improve the management. So when we say direct memory access or the DMA, it allows an adapter to transfer data directly from its own board buffers into the computer's memory, so without requiring the CPU to coordinate the memory access. So when we say shared adapter memory, it means that the adapter buffers map directly into the RAM on the computer. So when the computer thinks it's writing to its own memory, it is writing to the buffers on the NIC. So in this instance, the computer treats adapter RAM as its own. So in shared system memory, it means that the NIC's onboard processor selects a region of RAM on the computer and writes to its as if were buffer space on the adapter. So in this instance, the adapter treats computer RAM as its own. So in bus mastering, it permits a network adapter to take control of the computer's bus to initiate and manage data transfer to and from computer's memory. So in RAM buffering, it means that the NIC includes additional memory to provide temporary storage for incoming and outgoing data that arrives at the NIC faster than it can be shipped out. So this speeds overall performance because it lets the NIC process data as quickly as it can. So without having a pause occasionally to grab or send more data. So in onboard coprocessors, it included on some NICs permit the card to process the data. So without requiring service from the CPU, today most NICs include such as processors to speed the network operations. So the security features, it may be available on some high-end NICs, but these permit the card to handle several protocol functions, including the IPsec or the IP security and other encryption services related to authentication and payload protection. So IPsec or the IP security is a secure transport mechanism that gaining broad acceptance as a way to protect network traffic from unwanted snooping. So for workstations, slower cards may be acceptable on machines that use the network lightly. So increased availability, reliability, and manageability have obvious payoffs for servers that may not apply to workstations. So the following is a purchasing checklist for network interface cards. So the first one that you need in the checklist or in purchasing your, so the first one is the bus width, the bus type, memory transfer, special features required, bus mastering, and the vendor factors. So
hello everyone, I am Jonah Toledo and I will be discussing about wireless network adapters. So what is wireless network adapters? It is electronic devices that allow computers to connect to the internet and to other computers without using wire. Wireless network adapters usually include more gear than conventional cabled network interface cards. Such interfaces usually incorporate some or all of the following components. First is the under-antenna and the antenna cable. Second, the software to enable the adapter to work out with a particular network environment. Diagnostic software to check initial installation or to troubleshoot thereafter. And lastly, the installation software. The choices you must make when selecting a wireless adapter will depend on the speed at which you want to transfer data. The most likely choices will be 11 Mbps or 54 Mbps. Then you have to choose the appropriate wireless standard, which may depend on the type of wireless access point to which you must connect. The next topic is about the remote boot adapters. And in some situations, organizations may choose to use workstations without these drivers for a variety of reasons, including security, kiosk, and other public access applications. They often referred to as Tesla's workstation. Remote boot adapters offer several advantages. You can spend less because no hard drive is required and there is increase in security. The next one is about the drive software. It is a component that lets the operating system and a device to communicate with each other. And there are three major standards that apply to drivers that you should be familiar. The first one is the Network Device Interface Specifications, or the NDIS, and it is defined as a communications interface between the MAC sublayer and the network interface driver. NDIS allows network interface cards to use multiple protocols simultaneously. The WDM, or the Win32 driver model, defines a complete adapter card driver interface for PCs that run modern 32-bit Windows operating system. And lastly, the ODI, or the Open Data Link Interface, and it is quite similar to Network Device Interface but different enough to require a separate driver architecture. The following principles apply to more than just network interfaces. As a consequence, the operating system will communicate with the computer without having to interface any of the complexities of sending and receiving data from a piece of hardware. As you can see in the figure 4, this configuration information usually is necessary only with legacy network interface cards due to resource conflicts. Most plug-and-play network interface cards will install and use available computer resources without any user intervention. Whenever you plan to install any network interface card, you should try to determine if newer software is available because network interface cards driver software continually evolves. The network interface cards manual or the vendor's website on its technical support line are the good places to check for such information. It is usually easy to update a network interface card's driver than to install it because the only thing you need is a copy of the latest and the greatest driver. You should also know how to check from time to time to see if drivers change since your installation. Again, this is Jonah Toledo and I hope you get something from our short discussion. Thank you for watching.